Okay, so very quick introduction here to binary numbers. Just to let me select it and show it. Yeah, okay. So, right, ready to rock and roll here. So, binary numbers, as we say, the last day we were having a look at this, and I don't know how many you're familiar with, what do you call them? What's that called again? South Park? You're familiar with the Cartman and a few of them people, I don't know who is the chef. But a brief history of number systems. So where do numbers come from? And did we have a look at that one there last year there with James May? I'm not going to look at that, we'll have a look again. But it basically, because humans have 10 fingers, we count using a denary number system, base 10. And we count to 10, so we've got our ones, 1, 2, 3, 4, with 0 first of all, 5, 6, 7, 8, 9. And then when we get to 10, we have to introduce a new column and put a 1 in there, and you reset the right hand side, okay? And then you're off and running again, 11, 12, and you go up again, and you get to 20, and all the way up until you get to, I think it's 100. You go ones, tens, and then hundreds, and each time you're multiplying by 10. Do you see that? For each column. So 10 to the power of 1, 10 to the power of 2, 10 to the power of 0, 10 to the power of 1, 10 to the power of 2 is going to be the next one. And after that, 10 to the power of 3. And each time you're multiplying by 10, bringing it up there to thousands, 10 to the power of 4, and 10 to the power of 5, and so on. So decimal numbers there, the easiest way to understand bits is to compare them to something you know, digits. A digit is a single place that can hold numerical values between 0 and 9. Digits are normally combined together in groups to create larger numbers. So this number here, 6,357. Do we understand place value? Right, where does the 6, what does the 6 mean? That's thousands. What about 7? Ones. What about the 5? It's in the tens place. The 3 is in the hundreds place. And the 6 is in the thousands place. So, it's the more now you're doing just one second there. 2 hours, 2.5 hours. Oh, yeah. Thank you. So, in terms of place value there, that's fairly straightforward. And we can just see a background to it. 6 by the 1,000, 3 by the 100, 5 by the 10, and 7 by the 1. Does that all make sense? Should be fairly straightforward there. Another way to express it would be to use powers of 10. So look at here now the big difference. 10 to the power of 0 is what? A minute ago, that was 1, wasn't it? So look at these fellas here. That was 1, that was 10, that was 100, that was 1,000, wasn't it? Now it's going to become 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. Look at it. Yeah? The next one after that. So, just understanding that where it's coming from, and where you can see from this expression is that each digit is a placeholder for the next highest power of 10, starting as first. So that's all fine. And here's one for you, 25. What about 25? Will that be 5 by 10 to the power of 0? And 2 by 10 to the power of 1. Won't it? So that's for the straightforward 5 by 1 and 2 by 10, but changing it to the powers of 10. Here, 5 by 10 to the power of 0, which is your 5 by 1, and 2 by 10 to the power of 1. So I'm just trying to get across this idea, Avi, that each time it's a power of 10, the first rightmost place will be your ones, but that will be 10 to the power of 0, 10 to the power of 1, and the next one is 10 to the power of 2, and 10 to the power of 3, and 10 to the power of 4. So just be careful of that, 25. Here's one very quickly for you. Yeah, look, we'll go on there, it doesn't matter. Here's another one, 110. Can you just work that out quickly there and see can you get the same answer as me? Just work it out using your normal placeholder value and then change it into powers of 10. So the 0, how many ones is in the zeros place? Are in the ones position. How many, what value is in it? So 0 by 1, won't it? But what's 1 as a power of 10? 10 to the power of 0. Right, so that'll be your first one, look. because that 10 to the power of 0 there is really your ones. 10 to the power of 0 is 1. The next one there, this place, is a 1. That's in your, what place is that in? What place is it? Is it the tens? So in the tens, how many tens do you have? You have 1. So that'll be 1 by 10, but as a power of 10, that's going to be 1 by 10 to the power of 1. Won't it? And the next one, how many hundredths do we have? We've just 1, and again that's going to be 1 by 10 to the power of 2, which of course in our old way would have been your 1s, your 10s, and your hundredths. And we're just moving into a different idea there of kind of powers. And where I really want to show you that now is when we move into, there's another one, last one, again, 1 by 10 to the power of 0. Next one is going to be 1 by 10 to the power of 1. Next one is going to be 0 by 10 to the power of 2, because there's going to be nothing there, that'll be just 0. And the last one will be 1 by 10 to the power of 3. Right, so this is just a bit of a further background into the last day. And do we have any more there? No, so yeah, moving on. Right, what about binary? So binary, base 2, 2 states, and only 2 digits can be represented in the base 2 system, 0 and 1. So you've got this idea here of the binary number 1011. Now, the rightmost place, isn't that the 1s? The next one, what's it going to be? The 2s. The next one, 4s. The next one, 8s. The next one, 16s. In base 2. So previously in base 10, it was 1s, 10s, 100ths, thousands. Now it's 1s, 2s, 4s, 8s, 16s. So that's going to be 1 by 2 to the power of 0. Your rightmost place. This one is going to be 1 by 2 to the power of 1, 0 by 2 to the power of 2, and so on and so forth. But look at just a little bit of a background in there of where this is coming from as denary as opposed to to binary. So I'll just knock this off here. I don't know where it's gone on me.